In this video, we're going to look at two other classes of hydrocarbons, alkenes and alkynes. So far, we've looked at alkanes that just have carbon-carbon single bonds. With alkenes and alkynes, we're going to notice that we have at least one multiple bond. It could be a double bond or a triple bond. So in this video, we're going to look at their structures and different ways that we can write their structures. And we're going to start to name them. So let's get started. Let's have a look at the simplest alkenes. So alkenes are spelled A-L-K-E-N-E-S, like this, and these are hydrocarbons that have at least one double bond between carbons. I'll say carbon atoms. At least one double bond between carbon atoms. The general formula for alkenes is going to be Cn, so I'm going to have some number of carbons. The number of hydrogens is going to be twice the number of carbons. And this kind of makes sense because what we're going to notice with an alkene is if we make one of those single bonds a double bond, in that process we have to get rid of two hydrogens. And the general formula for an alkane was CnH, 2n plus 2. And if this one is CnH2n, it means we're getting rid of two hydrogens. So let's have a look at the first one. So let's have a look at C4H8. So I'm going to draw the first alkene we're going to look at. And let's call this one, actually let's not name it yet. There's our first alkene, and this is the line structural formula for it. This is 4-carbon alkene, and I want you to compare it to this 4-carbon alkane. If the line structural formula, we use one line to show a single bond. When we want to try to show a double bond, we just draw a second line parallel to that first line in the main chain. So this is 1, 2, 3, 4 carbons. And right here, we've got a double bond between carbon 2 and carbon 3. Another way that I could write this is with a fully expanded structural formula. So my carbon right on the end is that one right there. It has 3 hydrogens attached to it. Then when I get to this carbon has a double bond to the third carbon. So from this carbon's perspective, it has one single bond, a double bond. That means it has capacity for one other bond. And that bond will be to a hydrogen. So whenever you've got bonds other than bonds to carbon, once you eliminate those bonds to carbon atoms, you start to fill in the rest of the available bonds with bonds to hydrogen. Okay, so the same thing with this one, carbon 3 is going to have a hydrogen right there. Then we make a single bond to the last carbon. Sorry, Mr. DeHart was yelling at me like some sort of child. So here I've got my 4 carbons, and I've got a double bond right in the middle between carbon 2 and carbon 3. This structure is the same, it's representing the same molecule that we see here in this line structural formula. Okay, so the double bond is between carbon 2 and carbon 3. So what do we call this molecule here? Well, this is the first thing we're going to do is count all the carbons in the chain, the longest continuous chain of carbons. And I've got 1, 2, 3, 4. And I'll just label them here too. 1, 2, 3, 4. So the root is going to be bute, just like we would see with the alkane. So if we look at this alkane, it's got 4 carbons, nothing but carbon-carbon single bonds. We call that butane. This one here is 4 carbons, so it gets the root bute. But because it's an alkene, the suffix is not ane anymore, it's ene. The other thing we need to watch out for is where the double bond occurs. So the double bond occurs between carbon 2 and carbon 3. Now, once we start working with alkenes, we need to be careful about where the double bond occurs, and we need to use the numbering system to indicate where the double bond starts. So I'm going to contrast this molecule here with a very similar one, but it's different. In this molecule, the double bond starts at carbon 1 and ends at carbon 2. It has the same formula, the same molecular formula, but it looks a little bit different. And if you look at this one, it still has 4 carbons. So if I just label this as butene, well, this would also be called butene, and that's not good. I can't have any ambiguity. I can't look at the name butene and be able to draw 2 different structures for 2 completely different molecules. So there needs to be some more specificity in the name itself. So this is where the numbering system comes in. To indicate the position of this double bond, I need to include the number where that double bond starts. So with this molecule of butene, the double bond starts at carbon 2. So instead of calling it simply butene, I'm going to write bute hyphen 2 hyphen ene, E-N-E. So now this name says bute-2-ene. A few years ago, IUPAC changed the naming conventions. So some older textbooks or websites might call this 2-butene. Now it's called bute-2-ene. So it's a 4-carbon alkene with a double bond starting at carbon 2. So that's bute-2-ene. That's the correct name. With this molecule down here, I still have a 4-carbon chain, except where does the double bond start? It starts at carbon 1. So this is not bute-2-ene. This is called bute-1-ene. All right. So that you need to really pay attention to where the double bond occurs, starting with carbon chains that have 4 or more carbons. If you look at smaller ones, like this is the smallest alkene is this one here, a 2-carbon alkene. Here the double bond has no choice. It has to go between the carbons. And because there's 2 carbons in here, we would call this ethene. Okay, so that's ethene. If we have a 3rd carbon in there, like that, and then 3 hydrogens, last carbon. I've got 3 carbons in here, so that's the root prop, and I need ene as a suffix to indicate that it has a double bond. But I don't need to say prop-1-ene, because even though it starts at carbon 1, if I were to switch the double bond to this carbon, it would still start at carbon 1. I would just number from the other direction. So I don't need to write prop-1-ene. I could just write propene, because the double bond can only ever start at carbon 1, because there's only 2 places for it to go, and by definition, carbon 1 is where the double bond starts. But I do need to pay attention to where the double bond is once I get 4 or more carbons in my alkene. All right, so that's naming alkenes, or at least modeling them. We won't get into like naming them with branches or anything until the next video, but that's kind of basically how you name the alkenes. They have a general formula of CnH2n. With the last about 5 minutes of this video, I'm going to quickly go over how to name alkynes. Sorry, model and name alkynes. So an alkyne is just like an alkene, except we're going to take away 2 more hydrogens. So its general formula is going to be CnH2n minus 2. So we're taking away another 2 hydrogens. And an alkyne is a hydrocarbon with at least 1 triple bond between carbon atoms. And alkynes, start with like the simplest alkyne. It's actually quite similar, like the naming conventions are quite similar. That's why I don't spend a whole lot of time on it after I've introduced alkenes, because it's basically the same thing, except we use "-ine" instead of "-ene" as a suffix. So let's have a look at our simplest alkyne is C2H2. Is that right? C2H2? Yep, that's right. So this one is going to look like 2 carbon atoms. They have a triple bond, and since each one has a triple bond, they have a bonding capacity of 4. They have a capacity to hold 1 more hydrogen each. And there we go. We have a alkyne. I draw it as a straight line because if you remember your geometry and a valence shell electron electron pair repulsion theory, oh, that's a mouthful. The carbons here are going to have a linear geometry, and that's because they have a group of electrons here in the middle between the carbons, and then you have a second group of electrons, second pair of electrons over here between carbon and hydrogen. So you've got basically 2 electron groups pushing against each other, and the farthest they can get away is 180 degrees from each other. So these make straight lines, and the triple bond is very strong, it's very rigid, it doesn't bend. So everything will kind of, these 4 atoms stay kind of in the same line, okay, in space. So this is kind of, can be a little bit tricky when you draw the line structural formulas. When you draw the line structural formula for C2H2, and it's not a very common thing to see, but it would almost look like 3 lines because the points are carbons, and then the lines in between are showing the multiplicity of bonds. Let's have a look at another one. We'll look at C4H6. So I have 4 carbons. I'm going to draw my alkyne in the middle, my triple bond in the middle. Okay, and then each carbon on the end is going to have 3 hydrogens. I'm running out of room here. Let's just throw a third one right there. So what would this one be called? Well, I'm going to do the same thing. I'm going to count how many carbons I have. I have 4 carbons, so that would be the root of bute. And then the double bond starts at, sorry, not the double bond, the triple bond starts at carbon 2. So I'd call it bute-2-ine, like that, bute-2-ine. So once again, once I get 4 or more carbons, I need to indicate where that double bond occurs using a number. And I pick the carbon number where that double bond or triple bond starts. This one will look a little bit different when you draw the line structural formula because of the triple bond is so rigid and it's not allowed to bend. These 4 carbons basically stay in one line. So when you draw the line structural formula, it's going to look something like this, which looks very weird, but it's kind of how it is. And the line structural formula is supposed to tell us a little bit about how the atoms are oriented in space. So carbon 1 is on the end, and then once I get here, where the triple bond starts, that's carbon 2. It ends at carbon 3, and then the last carbon atom is carbon 4. All right, we'll do one more example. What happens if I get my triple bond right at the start? Like that. Well, that carbon can only have one hydrogen. This carbon can't have any hydrogens bonded to it because it has a triple bond to carbon 1, and then it has a single bond to carbon 3. So it has no more capacity for hydrogens. This carbon here can have 2, and the one on the end can have 3. So I got my 6 hydrogens in, just like my molecular formula says. Now when I name this, it's going to be a little bit different because now the triple bond starts at carbon 1. So when I name this, this is going to be called but-1-ine. All right, there you go. In the next video, what I'll do is I'll start adding branches, and we'll see what we need to do in terms of naming when we have a branch.